Dear students, let us continue with our discussion on trigonometric functions. In the last class, we have seen how to find the trigonometric functions of the sum or the difference of two angles like sin A plus B, sin A minus B, cos A plus B, cos A minus B, tan A plus B, tan A minus B, cot A plus B as well as cot A minus B. All those formulae are very important. Of course, their derivations also. Okay, so now let us look at some more relations, some more formulae. Okay, see these angles, the sum or the difference of two or more angles, they are also called as compound angles. Compound angles. Say if A and B are two angles, then A plus B, A minus B. If C is one more angle, then A plus B plus C, A plus B minus C, A minus B plus C. These are all called compound angles. Okay. So now let me just recall this formula. Sin A plus B is equal to sin A cos B plus cos A sin B. Sin A minus B is equal to sin A cos B minus cos A sin B. Then cos A plus B, that's equal to cos A cos B minus sin A sin B. Cos A minus B, that's equal to cos A cos B plus sin A sin B. Okay, and again you have tan A plus B, tan A minus B, cot A plus B, cot A minus B as well. Okay, now I will take this formula. The next formula is sin A plus B into sin A minus B. Sin A plus B into sin A minus B. This is equal to sin square A minus sin square B, or it is also equal to cos square B minus cos square A. Sin A plus B into sin A minus B is equal to sin square A minus sin square B. It is also equal to cos square B minus cos square A. We have to prove this result now. Okay, let me take this expression. Sin A plus B into sin A minus B. Sin A plus B into sin A minus B. This is equal to sin A plus B formula I will use. What is the formula? Sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B into sin A minus B. What is sin A minus B? Sin A cos B minus cos A sin B. Okay. Sin A cos B plus cos A sin B into sin A minus B, which is sin A cos B minus cos A sin B. Okay. Now this looks like A plus B into A minus B. Treat this as A plus B into A minus B. A plus B into A minus B is nothing but A square minus B square. A square minus B square. Sin A cos B whole square. That is nothing but sin square A cos square B minus A square minus B square. What is B square? Cos square A sin square B. Okay. Sin square A cos square B minus cos square A sin square B. That's equal to. Now I will keep this sin square A as it is. I will write cos square B as 1 minus sin square B. As we know, cos square theta is equal to 1 minus sin square theta. Minus. Similarly here, cos square A, I will write this as 1 minus sin square A into sin square B. 1 minus sin square A into sin square B. This is equal to, now multiply, we get sin square A minus sin square A into sin square B. Here minus 1 into sin square B, that is minus sin square B, minus and minus plus sin square A into sin square B. Okay. Sin square A into 1 is sin square A. Sin square A into minus sin square B will give you minus sin square A sin square B. And here minus of 1 into sin square B, that is minus sin square B. Here minus and minus plus sin square A into sin square B. So here this minus sin square A sin square B plus sin square A sin square B gets cancelled. So what will remain? that's equal to sine square A minus sine square B. So what did we prove now? We have proved that sine A plus B into sine A minus B is equal to sine square A minus sine square B. This is what we have proved. We have proved that sine A plus B into sine A minus B is equal to sine square A minus sine square B. This is what we have to prove. We have proved. But now we have to show that it is also equal to cos square B minus cos square A. We must also show that this is equal to cos square B minus cos square A. For that, this sine square A, I will write sine square A as 1 minus cos square A. Sine square A can be written as 1 minus cos square A. Minus sine square B, I will write it as 1 minus cos square B. Sin square B can be written as 1 minus cos square B. That's equal to, so this will be 1 minus cos square A minus 1 minus into minus plus cos square B. Okay, so 1 gets cancelled. Hence, you get cos square B minus cos square A. Okay. So we have sin A plus B into sin A minus B is equal to sin square A minus sin square B. That's also equal to cos square B minus cos square A. Okay. Next. See, all these formulae are important. Derivations are also important. You need to remember the formula as well as these derivations. Could be asked in the exam. Next, cos A plus B into cos A minus B. Cos A plus B into cos A minus B, that's equal to, this is equal to cos square A minus sin square B. Cos square A minus sin square B, that's also equal to cos square B minus sin square A. That's also equal to cos square B minus sin square A. Okay, cos A plus B into cos A minus B is equal to cos square A minus sin square B, and it's also equal to cos square B minus sin square A. Okay, we shall prove this now. Let me take this cos A plus B into cos A minus B. That's equal to cos A plus B formula we have. Cos A plus B. What is cos A plus B? Cos A cos B minus sin A sin B. This is cos A plus B. Okay. Into cos A minus B. What is cos A minus B? Cos A minus B is cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. So, cos A plus B into cos A minus B. Cos A plus B I have written it as, you know the formula, cos A cos B minus sin A sin B. Then for cos A minus B, the formula is cos A cos B plus sin A sin B. Okay. Now, this is like A minus B into A plus B. A minus B into A plus B is equal to A square minus B square. A minus B into A plus B is equal to A square minus B square. That formula you know. So, A square, what is A square? Cos A cos B whole square. That is nothing but cos square A cos square B. A square minus B square. B square is sin A sin B whole square. Sin A sin B whole square means sin square A sin square B. Okay. Next, see what you want to prove. You want to prove cos square A. You want to prove that this is equal to cos square A minus sin square B. I want cos square A minus sin square B. So what do we do? Observe, the angle A is in terms of cos and the angle B is in terms of sin. Angle A is in terms of cos. So, you retain this cos square A as it is. And angle B, what we want to prove is in terms of sin. So, write this cos square B in terms of sin. How can I write this in terms of sin? We can write cos square B as 1 minus sin square B. Then further, sin square A, I don't want sin square A, I want cos square A. So, what do? I will write sin square A as 1 minus cos square A. Then sin square B, we do need that sin square B. So, retain that sin square B as it is. Okay. So now if I simplify, this is equal to cos square A minus cos square A into sin square B. Here minus of 1 into sin square B, that will be minus sin square B, minus and minus plus cos square A into sin square B. Okay. So here minus cos square A sin square B, here plus cos square A sin square B, those two gets cancelled. So we have this is equal to cos square A minus sin square B. Cos square A minus sin square B. Okay, so we have proved this result. Now further we must show that it is also equal to cos square B minus sin square A. Cos square B minus sin square A. Okay, so here so far we have proved that cos A plus B into cos A minus B is equal to cos square A minus sin square B, right? This is what we have proved. We have proved that it is equal to cos square A minus sin square B. That's equal to cos square A. I want to say, now we want to prove that it is also equal to cos square B minus sin square A. Look here the angle B is in terms of cos and the angle A is in terms of sin. Angle A should be in terms of sin, angle B should be in terms of cos. So what do we do? I will write cos square A as 1 minus sin square A minus sin square B can be written as 1 minus cos square B. Sin square B is nothing but 1 minus cos square B. So this is equal to 1 minus sin square A minus 1 plus cos square B. Okay, 1 gets cancelled. So that's equal to cos square B minus sin square A. Cos square B minus sin square A. Okay. Now let's look at some problems. So far we have derived all these formula. You must remember all these formula. Of course the formula as well as the derivation you need to remember. Now let us solve problems based on this formula. So whatever the formula that we have learnt, with the help of this formula let us solve few problems. Okay, let's look at the first question. The first question is, find the value of sin 75 degree. Find the value of sin 75 degree. Okay. See, so far we only know how to find the value of sin 0 degree, 30 degree, 0, 30, 45, 60, 90 and then 120, 150 etc. Those things only we know. We know the trigonometric functions, the values of trigonometric functions of standard angles only we know. That does not mean that sin 75 does not exist or sin 36 does not exist. We do not know. We only know the trigonometric functions, trigonometric values of the standard angles. Now let us look at some more angles and see whether we can find those values with the help of any of these formulae. Okay. Sin 75 degree I want to find out its value. Okay. What I do is, I will write 75 degree as 45 degree plus 30 degree. Okay. 75 degree I am writing it as 45 degree plus 30 degree. This looks like sin A plus B. Now I can use this formula sin A plus B. Don't write this as sin 45 degree plus sin 30 degree. That is not correct, because sin A plus B is not equal to sin A plus sin B. Sin A plus B is equal to sin A cos B plus cos A sin B. Here in that formula I will put A as 45 degree and B as 30 degree. So sin 45 plus 30, that is equal to sin 45 degree sin A cos B means cos 30 degree plus cos A sin B cos A cos 45 degree into sin B sin 30 degree. Okay, sin A cos B plus cos A sin B. Now you know the values of all these. Let us substitute. Sin 45 degree 1 by root 2, cos 30 degree is root 3 by 2 plus cos 45 is 1 by root 2, sin 30 degree is 1 by 2. You know the values of all these. Here you have root 3 by 2 root 2 that plus 1 by 2 root 2. Together we can write this as root 3 plus 1 divided by 2 root 2. So, sine 75 degree is equal to root 3 plus 1 divided by 2 root 2. Okay. So, this value you should remember, and of course, this derivation also you have to remember. This could be asked for 2 marks. Find the value of sine 75 degree. See, if the question is asked for 1 mark, write the value of sine 75 degree, then directly you can write root 3 plus 1 by 2 root 2. If the same question, find the value of sine 75 degree, is asked for 2 marks, then you have to derive this. Okay, we know this formula, sin A plus B equals sin A cos B plus cos A sin B. With the help of that formula, you have to derive this. Okay. Now, some of you may be thinking, sir, why should I take 45 plus 30 only? 75 can be taken as 50 plus 25 also. Yes, you are absolutely right. 75 degree is equal to 50 degree plus 25 degree. But if I write in that way, then what happens here in the next step? We are going to get sin 75 cos 20, sin 50 cos 75 plus cos 50 sin 25. That is what you get, right? Sin 50 cos 25 plus cos 50 sin 25 you get. But I don't know what is the value of sin 25 degree, sin 50 degree, cos 50 degree, all those values we don't know. So, we will not be able to get the value, right? Hence, why did I write it as 75, why did I write 75 as 45 plus 30 only, is because I know these values. These are the standard angles, 45 degree and 30 degree. So, we were able to do it. Okay. Let us look at the next question. Find the value of sin 15 degree. Find the value of sin 15 degree. Okay, so you can easily predict what I am going to do. I can write sin 15 degree as sin 45 degree minus 30 degree. 15 degree can be written as 45 minus 30. 15 degree is nothing but 45 minus 30. Okay. Sin A minus B. What is sin A minus B? It's of the form sin A minus B. That formula I am going to use. Sin A minus B is equal to sin A cos B minus cos A sin B. So, this will be equal to sin 45 degree into cos 30 degree minus cos 45 degree into sin 30 degree. That is equal to sin 45 is 1 by root 2, cos 30 is root 3 by 2 minus cos 45 degree is 1 by root 2, sin 30 is 1 by 2. After simplification, we can write this as root 3 minus 1 divided by 2 root 2. This is the value of sin 15 degree. Sin 15 degree is equal to root 3 minus 1 by 2 root 2. Okay. Next. Find the value of cos 75 degree. Cos 75 degree. Okay. So, here also very similar to the previous case, cos 75, I am writing 75 degree as 45 degree plus 30 degree. Cos 45 plus 30. Okay. Now, I have to use the formula cos A plus B, 45 plus 30. So, cos A plus B formula, cos A plus B is equal to cos A cos B minus sin A sin B. That formula I am going to use here. This will give us cos 45 degree into cos 30 degree, cos A cos B minus sin A sin B, that is sin 45 degree into sin 30 degree. That's equal to cos 45 is 1 by root 2, cos 30 is root 3 by 2, sin 45 is 1 by root 2, sin 30 is 1 by 2. After simplification, this will give you root 3 minus 1 divided by 2 root 2. This is the value of cos 75 degree. Okay. See, already before deriving this only, you know these two formula. Sin 75 is equal to root 3 plus 1 by 2 root 2 and sin 15 degree is equal to root 3 minus 1 by 2 root 2. These two values, before deriving this only, you know those two formula, those two values you know. Actually, with the help of them also, we can obtain this. How? Let me explain. Say, cos 75 you want to find out, right? Cos 75 you want to find out. What I do is, I will write 75 degree as 90 minus 15. 75 can be written as 90 minus 15, right? 90 degree minus 15 degree will give us 75 degree. Now don't go for cos A minus B formula, because if I use cos A minus B, then I am going to get cos 90 into cos 15 plus sin 90 into sin 15. Then there I don't know what is the value of cos 15, that we haven't find out yet. But this looks like cos 90 minus theta, right? What is cos 90 minus theta? Don't tell me, sir, that was told 3 days ago. How do I remember? It should not be the case. You should remember if possible, throughout your life, or at least 2 years. Okay. So cos 90 minus theta, you should know that formula. Cos 90 minus theta is nothing but sin theta. So this is equal to sin 15 degree, and sin 15 degree value we already know, root 3 minus 1 by 2 root 2. In that way, you can directly write this. Okay. However, if this question is asked for 2 marks in the exam, obtain the value of cos 75 degree, then don't go for this. You have to do like this only. Okay. If it is 1 mark question, directly write cos 75 is equal to root 3 minus 1 by 2 root 2, and cos 15 degree is equal to root 3 plus 1 by 2 root 2. Okay, that I will obtain here only. Cos 15 degree. Cos 15 degree, that value again we can write it as 45 minus 30 and go in this way. In that way you can obtain that answer. Or you can write 15 degree as 90 degree minus 75 degree. So this looks like cos 90 minus theta. Cos 90 minus theta is equal to sin theta. So this is equal to sin 75 degree, and sin 75 degree value is equal to root 3 plus 1 by 2 root 2. So from this we observe that sin 75 degree is equal to cos 15 degree, that's equal to root 3 plus 1 by 2 root 2. Then sin 15 degree is equal to cos 75 degree, and that is equal to root 3 minus 1 by 2 root 2. Okay. All these values you should remember. Okay. Next question. Tan 75 degree I want. Find the value of tan 75 degree. Now you can either go for tan 45 plus 30, then use tan A plus B formula, or tan 75 degree can be written as sin 75 by cos 75, right? Tan theta is equal to sin theta by cos theta. What is sin 75 degree? Sin 75 degree, just now we have proved that it is equal to root 3 plus 1 by 2 root 2. And what about cos 75? Cos 75 is nothing but root 3 minus 1 by 2 root 2. So this 2 root 2 gets cancelled. What next? Root 3 plus 1 by root 3 minus 1. Don't cancel root 3, not allowed. Okay. Let us rationalize this denominator. I will multiply and divide by root 3 plus 1. In the numerator, root 3 plus 1 whole square. In the denominator, a minus b into a plus b, that is a square minus b square, root 3 whole square, that is 3 minus 1 square, that is 1. So root 3 plus 1 whole square, expand this using a plus b whole square. This is what you get. Divided by 3 minus 1 is 2. So 4 plus 2 root 3 divided by 2. Take 2 as a common factor, you will get 2 plus root 3 divided by 2, 2 gets cancelled. So the answer is 2 plus root 3. This is the value of tan 75 degree, 2 plus root 3. Okay, tan 75 degree is equal to 2 plus root 3. Okay, so here if this question is asked for 2 marks, you can do like this, no problem, because these many steps. So you can, it deserves 2 marks. If it is asked for 1 mark, find the value of, write the value of tan 75 degree, directly you can write 2 plus root 3. If it is asked for 2 marks, like obtain the value of tan 75 degree or find the value of tan 75 degree, then this is one way of solving this problem. Or another method is writing 75 degree as 45 plus 30. Okay. Then tan A plus B. Tan A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. In that way also you can solve this problem. Okay. Then also you will get the same value. You will and you should get the same value. Okay. After this, I will find out tan 15 degree. Okay. Tan 15 degree I want. Okay. Well, say tan 15 degree, you can write this as sin 15 by cos 15, and like what I did now, in that way you can obtain the answer. Or if you want any other method, I will write it as 45 minus 30. 15 degree can be written as 45 minus 30. This looks like, yesterday I derived one formula, tan pi by 4 minus a. Do you still remember the formula? This is equal to 1 minus tan a by 1 plus tan a. Do you know this formula? Tan pi by 4 minus a. In yesterday's video, this was our last derivation. Tan pi by 4 minus a is equal to 1 minus tan a by 1 plus tan a. Pi by 4 is nothing but 45 degree. Pi by 4 radians it is, that's equal to 45 degree. So, if I use that formula, this is directly is equal to 1 minus tan 30 degree divided by 1 plus tan 30 degree. Okay, this you can do. Or else if you don't know this formula, no problem, nothing to worry. Tan a minus b formula you know. ಅದು ಗೊತ್ತಿರಬೇಕಾ? ಓಕೆ, ಅದು ಗೊತ್ತಿರಲಿಲ್ಲ ಅಂದರೆ you can write tan 15 as sin 15 by cos 15. In that way you can do. Okay, so now if you don't know this formula, tan a minus 45 minus a is equal to 1 minus tan a by 1 plus tan a. If you don't know that formula, then you can use tan a minus b formula, tan a minus tan b divided by 1 plus tan a tan b. In that way you can get it. Okay, so then what is the value of tan 30 degree? Tan 30 is 1 by root 3, and so substitute here. See, I am not explaining much about the standard angles, tan 30 1 by root 3. You should know all those things. Okay, can't expect me to explain the same thing again and again. Take LCM here. Root 3 is the LCM. Numerator will be root 3 minus 1. Denominator, take root 3 as the LCM. Numerator becomes root 3 plus 1. This root 3 gets cancelled. So we are left with the root 3 minus 1 divided by root 3 plus 1. Right? Okay, let us rationalize the denominator now. So I am multiplying and dividing by root 3 minus 1. Numerator will be root 3 minus 1 whole square. Denominator a plus b into a minus b, that is a square minus b square. Root 3 whole square, that is 3 minus 1 square, that is 1. That's equal to, expand this, a square plus b square minus 2ab divided by 2. So 4 minus 2 root 3 divided by 2. Take 2 as common and cancel, we get 2 minus root 3. Okay, this is tan 15 degree. In the same way, we can obtain the values of cot 75 and cot 15 also. Secant 15, secant 75, cosecant 15, cosecant 75. Just taking the reciprocals, we will get the values of all those. Okay, next, let us take one problem now. Prove that cos 100 degree into cos 40 degree plus sin 100 degree into sin 40 degree is equal to 1 by 2. Prove that cos 100 into cos 40 plus sin 100 into sin 40 is equal to 1 by 2. Let me take this LHS. Cos 100 into cos 40 degree plus sin 100 into sin 40 degree. Okay, look at this. This looks like cos A cos B plus sin A sin B. This is of the form cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B. Cos A cos B plus sin A sin B, it is nothing but cos A minus B. So this is equal to cos A minus B. Here A is 100 degree, B is 40 degree. So 100 minus 40, that is 60. Cos 60 value is equal to 1 by 2. That's exactly what we want. Okay, then let's go to the next question. Sin 1140 degree into cos 390 degree minus cos 780 degree into sine 750 degree is equal to 1 by 2. So, this is also prove that sine 1140 degree into cos 390 degree minus cos 780 degree into sine 750 degree is equal to 1 by 2. This does not look like sine A cos B minus cos A sin B, because here if I take 1140 degree as A, but here you have 780 degree, right. So, these angles are greater than 360 degree. See, first I will write that sine 1140 degree into cos 390 degree minus cos 780 degree into sine 750 degree. That is equal to this 1140 degree, it is greater than 360 degree. You can subtract by 360 or subtract by any multiple of 360 degree. So, what I do is I will write I will subtract 1080 degree. Okay, 1080 is 360 into 3 into here cos 390 minus 360, 390 degree minus 360 degree minus cos 780 degree. There I will subtract 720 degree from it. Okay, 720 again it is a multiple of 360 degree into sine 750 degree. There 750 degree also I will subtract 720 from it. 720 is a multiple of 360 into 2. Okay, so this is equal to sine 60 degree. 1140 minus 1080, that will give you sine 60 degree into cos 30 degree minus cos 780 minus 720. 780 minus 720 is 60, cos 60 into 750 minus 720 is 30. So, sine 30. So, now this looks like sin A cos B minus cos A sin B. So, either you can directly substitute all these values and obtain the answer, or else you can use the formula sin A cos B minus cos A sin B. This is of the form sin A cos B minus cos A sin B. Sin A cos B minus cos A sin B, that is equal to sin A minus B. So, sin A minus B means 60 degree minus 30 degree. Sin 60 minus 30 is sin 30. Sin 30 degree is equal to 1 by 2. That is precisely what we want. Okay. Let me solve one more problem before I stop this class. Prove that cos square 52.5 degree minus sin square 22.5 degree is equal to 3 minus root 3 divided by 4 root 2. Cos square 52.5 degree minus sin square 22.5 degree. So, cos square 52.5 degree minus sin square 22.5 degree. This is equal to, okay. So, when we look at this expression, whether any formula comes to your mind, can we use any of these formula, cos A plus B, cos A minus B, sin A plus B, sin A minus B, anything like that? No? Look at this formula, cos A plus B into cos A minus B. Today only I have derived this formula, cos A plus B into cos A minus B. This is equal, I have derived this as, this is equal to cos square A minus sin square B, or it is also equal to cos square B minus sin square A, right? This is the formula we have. Now, look at this given problem. Does it look like cos square A minus sin square B? Cos square A minus sin square B, right? Cos square A minus sin square B. That is equal to what? Cos square A minus sin square B is equal to cos A plus B into cos A minus B. So, I can write this as cos A plus B. A plus B means 52.5 plus 22.5, cos A plus B, into cos A minus B. A minus B means 52 and a half minus 22 and a half. That's equal to cos 52 and a half plus 22 and a half will give you 75 degree. Cos 75 degree into cos 52 and a half degree minus 22 and a half degree, that's equal to 30 degree, right? 52.5 minus 22.5, that will be 30 degree. Cos 75 degree, what's the value of cos 75? Cos 75 is nothing but root 3 minus 1 by 2 root 2. You should remember all these things, okay? Then cos 30, it's a well-known value. What is the value? Root 3 by 2, right? That's equal to root 3 into root 3 minus 1. That if I multiply, root 3 into root 3 will give you 3 minus root 3 into 1, that is root 3 divided by 2 root 2 into 2 will give you 4 root 2. That's what we want. 3 minus root 3 divided by 4 root 2. Okay, students, with this I will stop today's class. Okay. Thank you. We'll continue tomorrow.